I'd now like to cover operational definitions and look at some thorny issues of measurement error, systematic and random error, criteria of measurement, reliability, and validity, and how you evaluate and remedy problems of reliability and validity. Operational definition. An operational definition completes the bridge between concept and measurement. It puts into operation, to use the same word, the idea, the measurement of the empirical property that's embedded in the conceptual definition. I've always preferred the term measurement strategy. I think it's more descriptive, but operational definition is a term, and you've probably heard the term before. Let's talk about this. Here's a very important distinction to think about when you're measuring something. You want to measure an intended characteristic. So if you've got to use a simple illustration, a test of math ability, you only want to test math ability. You don't want to test any other unintended characteristics with the measure that you're using, the operational definition that you're using. Acceptable operational definitions or measurement strategies measure the intended characteristic, and I should say, and only the intended characteristic, the characteristic specified in the conceptual definition. Acceptable strategies do not measure any unintended characteristics. Now, this might seem straightforward, but this is where a lot of mischief occurs. There's some famous examples of problems occurring at just this stage. Let's have a close look at it. Now, here's a hypothetical. It's a simple example. Then we'll look at a more complex example from the history of public opinion research. Math ability. Here's a perfectly serviceable conceptual definition. The concept of math ability is defined as the extent to which students, going to study this units of analysis, can correctly use basic mathematical operations. So you can think of those as being adding, subtracting, multiplying, and dividing. Here's how a hypothetical instructor operationalized the conceptual definition. Ask students to solve 10 word problems requiring addition, multiplication, division, and so on and so forth. Now, what's wrong with this operational definition? There's slippage between the conceptual definition, which is very good, and the operational definition, which is, one would say, deeply flawed. To be sure, some of the operational definition will in fact measure ability in math. That's intended, and it's in there. If you read these word problems, and you probably encountered these problems before, these sorts of problems. Read them, figure out the math operation that's required, and then compute the answer. But this math instructor is also picking up something you probably noticed. When you have to read these problems, that requires verbal ability to read and understand the words. Think of two students, both of whom inside them, sort of latent, have the same math ability. And you want a measurement that's going to measure that intended characteristic. But one of the students has a better verbal ability than the other student. So the students will be consistently, systematically mismeasured. The one with lower verbal ability, even though he or she has the same math ability as the other student, will be consistently measured as having lower math ability. So I put a frowny face on this kind of error. This is an example of what's called systematic measurement error. The problem with it is stitched into the strategy itself. It arises from inside the measurement strategy, which is using these word problems. Here's another one. This is also a systematic, durable characteristic that you don't want to measure. You don't want to measure students' test anxiety. Test anxiety systematically and consistently depresses math scores or any kind of test scores because it always affects the same students in the same way. It's durable. It doesn't go away quickly or overnight. And the next time you have the test, you're going to be measuring test anxiety as well. Verbal ability, test anxiety, these are, again, frowny faces because this is what I would call bad error, systematic measurement error. Now think of some other sorts of error, though. Suppose there's a fender bender or there's a crowd trying to get into campus for a football game or something, and some students arrive late. these students would ordinarily be on time, and next time they will be on time, or maybe even early. But because of this event that intrudes from outside the measurement context, uh, the students will be in a hurry, they won't be focused, and their grades may be depressed on the exam. But it doesn't come from inside the measurement strategy itself, and it's not durable. It's happenstance. Here's another one that bounces in. It might be commotion outside the classroom or out in the hallway. Uh, uh, some students may be ill or tired. You know, you've done this before. We've been you just haven't felt well. The next day or the next week, you feel perfectly fine. But these factors create noise in a measurement. They create random measurement error that doesn't inhere in the measurement strategy itself, but intrudes from outside. That's a key distinction. There's two kinds of unintended characteristics. Durable, consistent unintended characteristics that arise from inside the measurement strategy itself. And here are those examples again: verbal ability, test anxiety. Test anxiety is an example of what are called reactive measurement effects, or a Hawthorne effect. That one arose in I think it was the Human Relations School of Occupational Psychology found that, when people know that they're being measured, they perform a lot differently from when they don't think they're being measured. These are durable, consistent, unintended. Other factors are temporary and inconsistent unintended characteristics that intrude from outside the measurement strategy. These aren't part of the operational definition. They just create noise and randomness, happenstance, that inconsistently affect different students' performance on this hypothetical math exam. All right, with these two kinds of unintended characteristics in mind, we can begin to talk about relatedly two kinds of measurement error. Systematic error, systematic measurement error, consistent unintended characteristics. Factors that do not change over time, change slowly if at all. Arise, I keep emphasizing this point because this is key, arise from within the measurement instrument itself. You can't, you have to completely reform the measurement instrument in order to get rid of these sources of systematic error. They always affect the measurement in the same way. Think about systematic error. We might realize we have some systematic measurement error, but we almost never, in fact, I'd have to say, we never know to what extent it's affecting a measurement. To take an example of a systematic error that is how it's affecting your measure. I mean, if you were to measure, say you weigh your dog, how do you get an accurate measurement of your dog's weight? Well, you get on the scale, weigh yourself, then you pick up your dog and stand back on the scale and weigh you plus the dog. And of course, the amount of systematic error that you've introduced. It's your weight. So you just subtract that bias or that systematic error out and you have the weight of your dog. The reason I'm using this whimsical example is to illustrate that in almost all of the cases, we don't know how to estimate the size of systematic error. That's what makes it so pernicious. All right, good error. We've always got some random error in here. Inconsistent unintended characteristics. Temporary or idiosyncratic. Intrude from outside the instrument. Do not affect the measurement in the same way every time. A student who's ill, now their score is depressed. Next time they feel well, their score is enhanced. So there is this, again, noise-like quality to random error. It doesn't have a consistent systematic effect. All right, let's talk about a political science example of a systematic measurement error, and this is from the tradition of public opinion research. Scholars beginning really after World War II, you go back to the 1950s, became very interested in political tolerance. And here is a serviceable conceptual definition of political tolerance. The concept of political tolerance is defined as the extent to which individuals, and it's almost always studied at the level of individuals, exhibit the characteristic of expressing a willingness to allow basic freedoms to unpopular groups. So basic freedom, of course, would be the freedom of speech, freedom of assembly, freedom to write and have books in a public library, for example. You can think of how you would concretize or come up with the concrete measures of basic freedoms. And here is an early way that it was operationalized. This definition was operationalized. This is the Samuel Stover tradition in public opinion. Ask respondents a series of questions that gauge whether they believe basic freedoms and procedural safeguards should be extended to communists, atheists, and socialists. This was, again, the traditional way of measuring political tolerance. Unpopular groups, to what extent do people extend freedoms? For example, here's a Stover question, measured tolerance. Should an avowed communist be allowed to make a speech? I think he said in your community. You could make it specific to your university or college. Should someone who opposes God and religion be allowed to have a book in the library? What's wrong with this measurement strategy? I mean, the one thing we came to realize about this was there were two referents in these questions on tolerance. One, of course, was tapping some amount of political tolerance. I mean, obviously, if you're willing to extend basic freedoms to all groups, then you would be measured as having tolerance. But some amount of the measurement was tapping ideological leanings or sympathies. I mean, imagine if you are a communist, you can't by definition tolerate communists because you are one. You know, a later measurement specified that tolerance implies that you object to a group. You can't tolerate a group that you don't object to by definition. So this measure was reformed by John Sullivan and his associates later on to allow the respondent, him or herself, to pick a group that they find distasteful, that they dislike, and then ask those tolerance questions about that group. Allow respondents themselves to identify groups they dislike. That untethers the measurement from an ideological target and allows the respondents themselves to anchor their thoughts of tolerance toward groups that they personally do not like. And so it purged the earlier measure of its systematic bias, a systematic measurement error, which was also picking up ideological leanings.